Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Sampling the solar system. This video discusses the human obsession for understanding the movement of celestial bodies and how the study of the properties of light has made it possible to deduce the chemical composition of the stars and planets. "The moon is made of green cheese" was one of the most popular proverbs in the English literature of the 16th and 17th century, and we still hear this phrase today. The phrase likely originated from the Proverbs of John Haywood, published in 1546, which said, "The moon is made of green cheese." Humans have always been curious about the moon, the stars, and the planets, but without a way to examine their true nature, they have invented fancy stories. Some of these stories end up as nursery rhymes. "Hey, diddle diddle! The cat and the fiddle. The cow jumped over the moon. The little dog laughed to see such fun. And the dish ran away with a spoon." This rhyme may date back to at least the 16th century, and some references suggest that some version of this saying may have been around for more than 1,000 years. In earlier times, the celestial bodies were not the subject of such light-hearted amusement. From the dawn of man, people have been aware of the great influence of the sun and the moon on the earth. The seasons are ruled by the orbit of the earth around the sun. The polar axis of the earth is tilted at 23.5 degrees from the plane of its orbit. This means that the northern hemisphere is closer to the sun in the summer, while the southern hemisphere experiences winter. Half a year later, when the Earth has traveled halfway around its orbit, the situation is reversed and winter engulfs the northern hemisphere, while the southern hemisphere basks in the warmth of the sun. The moon, in concert with the sun, dominates the tides. The oceans slosh around the Earth, pulled by the gravitational attraction of the moon. The height of the tides is influenced by the sun. High spring tides occur when the sun, the moon, and the earth align in a straight line. Neap tides occur when the sun and the moon are at right angles to the earth and pull in different directions. This happens when the moon is in its first and third quarter phase. When viewed from the rotating earth, the sun, the moon, the planets, and the stars seem to move from the east to the west. We don't feel the rotation of the earth, so it seems logical that the earth is standing still and all the heavenly bodies revolved around the earth. In the 2nd century AD, Claudius Ptolemy, a mathematician and astronomer born in Alexandria, Egypt, standardized a geocentric system where all the planets and the sun revolved around the earth. The planets moved in epicycles to adjust for the seasonal variations. The Ptolemaic system remained the standard explanation of the heavens for 14 centuries. The Egyptians studied the movement of the earth very diligently. More than 2,500 years before Ptolemy, the Egyptians had built the Sphinx facing east, and the pyramids were oriented along the cardinal points. The Egyptians established religions based on the celestial bodies and imagined powerful deities with characteristics of humans and animals. The sun god Ra was represented as a human body with the head of a hawk. Ra was believed to sail across the sky in a boat each day and then make a passage through the underworld each night, during which he would have to defeat the snake god Apopis in order to rise again. Khonsu was the ancient Egyptian god of the moon. The name Khonsu means the traveler or the wanderer, which refers to the moon wandering across the night sky. Khonsu was also revered as the god of time, probably because the Egyptians used a purely lunar calendar prior to the establishment of the solar civil calendar. Khonsu was portrayed wrapped like a mummy with a headdress of a full moon cradled in a crescent new moon. Egyptians believed in life after death. Anubis was a jackal-headed god of death, mummification, embalming, the afterlife, cemeteries, tombs, and the underworld. Anubis presided over the embalming process and accompanied the dead in the underworld. The constellation of Orion seems to have been of particular importance to the Egyptians. The Orion constellation is named after the hunter in Greek mythology. The 3 stars that form Orion's belt have a particular alignment that seems to correspond to the relative positions of the pyramids. In 1994, Robert Baubal proposed the Orion correlation theory, which states that there is an intentional correlation between the location of the 3 largest pyramids of the Giza pyramid complex and Orion's belt. This has been criticized as a fringe theory by Egyptologists who argue that the alignment is coincidental and not intentional. The Egyptians were not the only ones who spent a lot of effort building pyramids. Teotihuacan was the first large metropolis in the Americas with a population of 125,000 to 200,000 inhabitants. It is the site of some of the most architecturally significant pyramids built by civilizations that inhabited Mexico. The city was abandoned in the 7th century. It is unclear why Teotihuacan collapsed, but around 600 AD, major buildings were deliberately burned and artworks and religious sculptures were destroyed. The Aztecs found the abandoned city in the 1400s and named it Teotihuacan, which means place of the gods in Nahuatl, which is the language spoken by the Aztecs. Nahuatl is not a dead language. It is spoken today by approximately 1 million people in Mexico. I climbed to the top of the Pyramid of the Sun. The pyramid rises 66 meters or 216 feet above ground level. On the pyramid's west side, there are 248 uneven stair steps that lead to the top of the structure. The climb is made harder by the rarefied air at an altitude of 2,280 meters or 7,480 feet above sea level. This is a picture of the Pyramid of the Moon viewed from the top of the Pyramid of the Sun. Notice that the Pyramid of the Moon is precisely centered at the end of the Avenue of the Dead. The Central Avenue of the Dead extends more than 1.5 miles from the Pyramid of the Moon to the Temple of Quetzalcoatl. Visitors use this main causeway to walk between the archaeological sites. The names of the pyramids were given by the Aztecs. We don't really know whether the builders of the pyramids intended to venerate the sun and the moon. The Avenue of the Dead is oriented approximately 16 degrees northwest, and it is aligned with the setting sun on specific dates. But this brings up the question of why the Pyramid of the Moon is exactly at the end of the Avenue of the Dead. Perhaps the alignment with the moon needs to be investigated further. The Aztecs lived in Tenochtitlan, the historic center of Mexico City. This is adjacent to Mexico's National Palace, which is the office of the Mexican president. This picture is a scale model of the Templo Mayor, or main temple of the Aztecs. The Spaniards who conquered Mexico destroyed many of the temples and built churches upon them in order to convert the indigenous people to the Catholic religion. Many archaeological discoveries in Mexico are made during the subterranean excavations that are needed to deploy modern infrastructure. A museum next to the Templo Mayor displays a large number of the archaeological articles that have been found here. Like the Egyptians, the Aztecs had a sun god, but his name was Huitzilopochtli. The Templo Mayor had two stairways to access the two shrines on the top platform. The shrine on the left was dedicated to Tlaloc, the god of water. The shrine on the right side was for Huitzilopochtli, the god of war and of the sun. Unlike the Egyptian god Ra, who sailed across the sky in a boat each day and had to fight the snake god Apopis during the night in order to rise again, Huitzilopochtli required human sacrifices in order for the sun to rise in the morning and protect the Aztec people from an infinite night. A sacrificial victim was placed on a stone altar, and then a priest would make an incision through the abdomen with an obsidian blade and cut out the heart. The heart, still beating, was held toward the sky in honor of the sun god. It is not surprising that the Spaniards were horrified by these rituals and destroyed the temples, but it should be mentioned that the tortures of the Spanish Inquisition to combat heresy were more cruel because they were designed to inflict pain and suffering rather than to kill the victim quickly. The Aztecs developed a calendar to keep track of the passage of the seasons. The circular calendar stone measures 3.7 meters or 12 feet in diameter and weighs 25 tons. It was uncovered in Mexico City in 1790 and is currently on display in the National Museum of Anthropology in Mexico City. The movement of heavenly bodies was very important to many ancient civilizations, and they built structures to observe the sky. The Maya used the Caracol Observatory in Chichen Itza in the Yucatan Peninsula. Some people pronounce the name as Chichen Itza, but the Spanish pronunciation Chichen Itza, with the stress on the final syllables, is more consistent with the Mayan pronunciation. The Temple of the Sun in Machu Picchu in Peru was built by the Incas to track the sun. A trapezoid window is positioned along its curved wall to capture sunlight during the winter solstice. The Inca worshipped Viracocha as the god of the sun and storms. He was represented as wearing the sun for a crown, with thunderbolts in his hands and tears descending from his eyes as rain. The Stonehenge is a prehistoric monument in Wiltshire, England. Archaeologists believe it was constructed from 3000 BC to 2000 BC. The site is aligned in the direction of the sunrise of the summer solstice and the sunset of the winter solstice. The ancestral Puebloans who inhabited Chaco Canyon in New Mexico between 900 and 1150 AD carved some petroglyphs and placed some stones to track the seasons. The Sundagger site in Fajada Butte lets a beam of light fall at about 11:15 a.m. upon the center of a spiral during the summer solstice. The invention of the telescope greatly improved our understanding of the heavenly bodies. Rather than imagining the planets as powerful gods, we realized that they were worlds like the Earth. On November 30th, 1609, Galileo aimed his telescope at the moon, and he was able to deduce that the features of the moon were mountains and craters. From the lengths of the shadows, he was able to estimate the heights of the mountains. Galileo published his illustration of the moon in 1610. Between the years 1609 and 1619, Johannes Kepler made very careful observations of the planets, and he was able to describe the orbits of the planets around the Sun. Kepler figured out that the orbits of the planets were elliptical and not circular. He found 3 mathematical relationships that could explain the movements of the planets. These are now known as Kepler's laws. 1. The orbit of a planet is an ellipse with the Sun at one focus. 2. A line segment joining a planet and the Sun sweeps out equal areas during equal intervals of time. 3. The square of a planet's orbital period is proportional to the cube of the length of the semi-major axis of its orbit. Kepler's publications provided some of the foundation for Newton's theory of universal gravitation, which he published in 1687 as a mathematical treatise, the Principia Mathematica. Newton derived an equation stating that the gravitational force attracting two bodies is equal to the product of a gravitational constant g multiplied times the product of the masses divided by the square of the distance between them. Newton's equations are still used today because they are very accurate at non-relativistic speeds and low gravitational fields. Newton was interested in many scientific disciplines, including optics. In 1704, he published a treatise on the reflections, refractions, inflections, and colors of light. Newton invented the reflecting telescope, which uses mirrors instead of lenses. The telescope has the advantage that the light is not distorted by the lenses, and it can be a lot smaller than telescopes that use lenses. The Hubble Space Telescope and the James Webb Telescope that will replace it are both Newtonian reflecting telescopes. Space telescopes produce very clear images because they avoid distortions created by the Earth's atmosphere. Isaac Newton had studied the spectrum of sunlight in great detail, but he overlooked something. In 1814, 110 years after Newton published his treatise on optics, Joseph von Fraunhofer, an optical lens manufacturer, discovered dark lines in the spectrum of the sun. These lines are now known as Fraunhofer lines. Germany issued a 1987 stamp commemorating the 200th anniversary of Fraunhofer's birthday. At the time of this discovery, nobody knew what caused the dark lines. About 45 years later, Gustav Kirchhoff and Robert Bunsen, who invented the Bunsen burner, noticed that several Fraunhofer lines coincide with characteristic emission lines identified in the spectra of heated elements. It became evident that the dark Fraunhofer lines were absorption lines. Kirchhoff developed 3 laws of spectroscopy. 1. A solid, liquid, or dense gas excited to emit light will radiate in all wavelengths and thus produce a continuous spectrum. 2. A low-density gas excited to emit light will do so at specific wavelengths, and this produces an emission spectrum. 3. If light composing a continuous spectrum passes through a cool, low-density gas, the result will be an absorption spectrum. Law number 1 explained Newton's observations. Law number 2 explained the flame experiments with the Bunsen burner. And law number 3 explained the dark Fraunhofer lines. With this information, it was now possible to sample the chemical composition of heavenly bodies by using the light that they emitted. Kirchhoff did not know about the existence of energy levels in atoms. The existence of discrete spectral lines was explained in 1913 by the Bohr model of the atom that eventually helped to establish quantum mechanics. In this model, a small dense nucleus with protons and neutrons is surrounded by orbiting electrons. When an electron shifts from a higher energy orbit to a lower orbit, a corresponding quantity of energy is released. The frequency of the released energy is characteristic for the element. Astronomers have found that when the spectrum of faraway stars is examined, the Fraunhofer lines are usually shifted. This image shows how the pattern of lines of an element can shift toward the red part of the spectrum. This is called the red shift, and it is associated with longer wavelengths. The longer wavelengths can be explained by the Doppler effect. A wave produced by a moving object is perceived as having a higher frequency when it approaches and a lower frequency when it is moving away. In 1929, Edwin Hubble published an article showing that galaxies are moving away from the Earth at speeds proportional to their distance. In other words, the farther they are, the faster they are moving away from the Earth. The rate of expansion leads to the conclusion that the universe originated in a Big Bang. The velocity of the galaxies has been determined by their red shift, and the spectral analysis enables us to sample the chemical composition of celestial objects from the light that they emit. Apollo 11 was the space flight that first landed humans on the Moon in 1969. The astronauts carried the first geologic samples from the Moon back to Earth. They collected 22 kilograms of material, including rocks, fine-grained lunar regolith, and core tubes that included material from up to 13 centimeters below the Moon's surface. The samples from the Moon do not have mineral hydration like samples from the Earth, but the stable isotope ratios of lunar and terrestrial rock are identical, implying a common origin. This has given rise to the giant impact hypothesis, which states that the Moon formed from the ejecta of a collision between the proto-Earth and a Mars-sized planetesimal named Theia, approximately 4.5 billion years ago. The off-center impact tilted the axis of rotation of the Earth by 23.5 degrees. Now, we know for sure that the Moon is not made of green cheese. We no longer consider celestial objects to be gods, although these heavenly bodies still affect our daily lives like they did our ancestors. Our progress in science has enabled us to see the Earth from a new perspective. We are the last remaining branch of a long line of hominins. We should take care of this Earth and each other to prolong our existence on this planet, because sooner or later the death god Anubis will come for us. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.